What's up, guys? I'm in here running some parts that my brother Andy programmed, and I just wanted to kind of show you guys what goes into us creating our billet parachute handles, and just like the process. A lot of people think it just spits it right out. It is pretty quick and it's efficient, and I don't actually get to run this machine very often. Andy finally let me run it because I was going to be in this weekend. But I'll kind of show you the process. Each one of these things takes a number of minutes to make, and there's a lot that goes into them, quality control and everything. One of the reasons why we moved all of our part building in-house is that we wanted to be able to control the quality and the look. Some machine shops don't really care about aesthetics because a lot of the parts go into like building tractors and stuff like that nobody really cares about the finish and quality. So we decided we were going to move everything in-house and really start doubling down on R&D and then also production, so we can kind of control the whole supply chain, I guess you would call it, and then also make sure we're getting exactly what we want and what you guys want. So I figured I would kind of show you like loading the parts, how it all works, making it, how we quality check it and everything. So I figured I'd go live for that because it's just easier than making a video and posting it somewhere. Anyways, right now it's finishing up the program. There's two steps to this program. First, we take a raw block of aluminum that we chop up on our automatic bandsaw. So on this bandsaw, we just load up a stick of aluminum, and it cuts it to predetermined lengths, and it just keeps going down the road. And then we'll just deburr it and then get it ready for the first step of the process. As you can see, there's two vices loaded in there. We'll load the raw block into one, and then what happens is it does the first process, and we'll flip it over and load it into the second one. So technically right now we have a step 1 going and a step 2 going at the same time. So it'll machine the first side, then we'll pull it out of the vise, flip it over, and it'll finish the second side. And we'll get this finished piece out of it when we're all done. M. Grody, we don't have a precision blow-off valve in stock. They're on back order for like 6 to 8 weeks. So we do have the Turbo Smart power ports in stock. Those are badass units. They're 64 millimeter. They flow just as much as a precision, and they're a little bit smaller. So that's a good option for you since they're out. Anyways, this program is about finished up, and then I'll show you how we kind of load them all in there. Do you guys have any questions for us? We're running these programs on Haas VF2. We got this in July, I think. And Andy, my brother, had never run a CNC machine before, but he's a super smart dude. His background, he's a mechanical engineer and a design engineer. So he does, up until a few months ago, all of our design work. Now we have a couple other guys on board, Tyler and Mitch. And he kind of took over as far as learning how to program this machine. What you guys don't realize is when you can draw a part out on a CAD part, and after that you also have to program it into this, which there's programs that really make it easy, but there's a lot of optimization that goes into it. None of those programs are perfect. They'll crash parts. So it's not really just like a plug and play and go type of deal. You have to kind of sit there and babysit it for a couple days. And what Andy will do is he'll put a part on here, and he'll visually watch it and understand how he can save time between each step and speed up the whole process, because you know, if you can take a part from 45 minutes to 30 minutes, time's money. And for us, we only have one machine currently. This is our first machine that we bought and have, and we're just making this thing hump. So, what's up, Drag Cars with a Z? Butch Kemp's in the house. He's probably wanting to get a look at my Nova. It's not here, it's in the trailer. But yeah, anyways, it's a pretty interesting process. especially when you get to run it a little bit on the weekends. Luckily, Andy's letting me run this thing now. So, open the door here. You'll see that there's a tool changer up there. So that has all the different bits. They'll have milling bits, drill bits, chamfer tools, end mills, taps. Right now we're running our billet parachute handles. So these are fixtured up. So what you'll see here is that this is the first side done. This one came from the solid block of aluminum, and then this is the finished part. So this vise, we'll just go ahead and knock it open, and you'll see that this is the finished parachute handle right here. This thing's super nice. I'm gonna set this phone up here real quick while I wipe this off. So once the part comes out, we'll actually visually inspect it to make sure it didn't shift in the vise at all, or fixture. Some of the parts we have fixtures for that we run huge volumes of, but you'll see that it's just a beautiful piece of billet aluminum now. So we'll go ahead and put that on the pile here. I don't typically run this machine. They usually don't let me touch things that move around a whole lot, except for welders. So this one is the first side done here. What we'll do is we'll flip it over, and so what we do is we machine what are called soft jaws to hold it. So it'll go in there, and as you tighten it up, you'll see it just kind of pulls it into that that mold there. And so that's actually another process. Tap it down so it's comfortably in there, and tighten that sucker down. And then the other side is going to get one of these billet or raw stocks. It's going to get loaded in here, and then we have like a fixture block here. So what that fixture block is it replicates that it hits the same spot every time, because that's obviously what we're trying to do. Is we're trying to replicate it and make it hit the same spot every time, so that the program knows where to pick up this block of raw aluminum. So what we'll do is we'll tighten this vise. Tap that sucker down. Make sure it's all the way down in the fixture. Tighten it down. And so now you have a raw piece of aluminum here. And then you'll have this, our first step is done on this. You can see the holes come through all the way. It's already been tapped and drilled through. So what'll happen is it'll take this mill here and knock all of this down, and then it'll come back and profile edge that whole piece right there. And then you'll see all the chips just go out the chip auger in here. So this will be getting the first op, and this will be getting the second op. Be honest, it's Haas VF2. So now that everything's loaded, I think we're ready to go. The machine's hopefully not gonna crash, but we'll just hit cycle start here. So now you can see it's actually changing tools right now. It's gonna load that face mill up, which it has through spindle cooling. So what that means is there's actually coolant that goes through the tooling, and what that does is it lets the tool live longer, and it also gets the chips away, so you have a better surface finish. So now it's gonna go and profile that handle. That's the raw stock of aluminum. You're gonna see it profiles the whole handle itself. And if you can see, it's just shooting chips out. So this is an end mill that it's just doing rough cuts with right now. And it's just taking that square piece and turn it into the profile of that aluminum handle. If you can see in there, the coolant kind of sprays everywhere. But the coolant is, it's what makes our tools live long, and it's also what, if it's spraying at that high pressure, it keeps it so that you get that shiny finish with you know, just a good surface finish, the finish that all of us car guys want, that makes it shiny and makes all your friends jealous. So right now it's doing a chamfer on the edges with the final cut here. And then you'll see it's going to profile that other piece, and pretty soon we're going to have just a finished handle on that side, because the first process and drilling and tapping's already been done on it, so pretty cool really. So Texas Z06, definitely there's better and faster ways to do it. This is a seemingly low run piece, and this is actually our first run in-house of these. So what we're doing right now is we're kind of setting programs up, and we're starting to optimize them. So, you know, since we're only running a couple hundred parts of these, it's not all the parts are worth creating big intricate fixtures, but as we get going and we have higher volumes of certain parts, we'll make the fixtures to hold them. So yeah, I think there's probably more optimal ways you could probably do it, and as far as setting more pieces up on the table at a time. But for some parts, if it's our first run, we're just basically trying to create the process and make sure it works, and then later we'll either set it up on a vacuum table or make up more of a dedicated fixture for it, so it's not just vice work. So right now it's coming back on that first piece and doing a finish cut and cleaning up the edge so that it doesn't have a rough cut on it. I'm not sure what the max size on a VF2 is, to be completely honest. The table, by the time you put a couple of vices on, is actually relatively small. We're going to be getting some new machines at our next location that are bigger, ones that have 4th and 5th axes. This has been a great machine, I feel like, for getting into what we're doing, because it does most of the products that we make. It's big enough, and it wasn't too daunting. Well, I should speak for myself. Andy probably might disagree, but it's been very useful for us, and it does a lot of what we want it to do. I'm sure we could be faster and more profitable and make more parts at a time on a different machine, but it works out really well. So right now it's drilling the holes in there. It's actually, these things actually like peck holes in material instead of going right through. That way it gives it a better surface finish inside the hole, because it pulls the chips out, so it doesn't drag a bunch of chips all the way through the hole. And that gives you a more accurate and better finished hole for like press fits and all that type of stuff. And right now, I'm not sure what it's doing here. It's doing a chamfer on the holes at the moment. We've been super happy with the Haas stuff, Texas Z06. Their customer support's been fantastic. The whole buy-in process is great. A lot of good support with them. A lot of good information out there. And you really can't beat it for the price. So I'll show you guys while I'm running parts today. I'm finishing up our Blue Mule Camaro. I just finished the interior last weekend. Almost dropped the phone. I finished the interior last weekend. It's all put back together. 850 cage. All the electronics are done. Wiring's done on the inside. So we should be able to start it up later this week. As far as the car itself goes, putting the engine bay back together this week. I got to tidy up. I put the MSD 2-step on it. I'm just tidying up the engine bay, and I hope to have it together and running sometime this week. This weekend I'm hoping to have the whole car together and So while this thing's running programs on those parts, I'm actually just going to be working on this thing, kind of a dual purpose deal. One of the cool parts of a CNC machine. So anyways, right now it's cutting some back cut profiles in the parts just to lighten it, kind of give it some better aesthetics. I don't think I spilled any coffee on the radiator. Yeah, maybe. It's tea, actually. It's hot tea. Do you guys have any other questions? I just thought it'd be kind of a cool tutorial. Show you kind of the behind the scenes at Motion. Teddy. Of course, the shop dogs are with us today. And then that's another S550 project we're working on right now. What's up, Red Civic guy? Yeah, Steamboat get made on this as well. We actually have some center blocks that were made a week or two ago, just sitting here ready to be engraved. So right now, it's tapping holes, which that's pretty wild. It basically just goes, it just dives that tap in, and it has a pre-calculated amount of times it spins in, and then it reverses it and comes back out. Pretty wild stuff, really. But one of the cool things about this whole machine, in my opinion, is we can say that our parts are made in USA. They always have been, but it's really interesting. There's a lot of upfront work in it, and a lot of heartache and money invested in all of that. But you get to the point where it's actually doable, and it's really cool to have some pride in what you do and know that your parts aren't coming from some overseas sweatshop. And I think that's really cool. That's something we can hang our hat on. We design it in-house, we build it in-house, we send it to people. There's no SARS or anything on the parts. And it's just cool to know where they come from. And honestly, as we're getting better and faster at things, moving it in-house, we've actually noticed that we can actually decrease prices on some parts, which is really cool because a lot of people think you can only decrease parts when you outsource parts. We can actually decrease them by insourcing them. So I think it's a different approach that other people aren't taking, and it's really starting to pay off for us. We got all kinds of new parts coming out in the next couple months. I would say we are starting new part design and production in about 300% to 400% faster than we did this time last year. So our goal this year is about 150, 200 new parts, and we're really excited about that. This machine and then the few that we're going to be ordering for our next shop that we're going to be moving to in a few months, they're really going to be working overtime, but it's really cool to know we can take it from concept to machine in the house and do it cheaper than some of these guys that are exporting stuff. And then you also don't have to worry about tariffs, and you don't have to worry about all these political climates and transport and hoping that you get some good quality. We know the quality is good because we just throw the part away if it doesn't turn out nice. But anyways, I'm a little long-winded, but I just thought I would show you guys kind of our whole process. This is your finished product. So this is stage 1. This one will get flipped over to here, and here's stage 2 finished product. We got a pile of them here, and this is what it turns out to be. So this will get packaged up next week and start going in parachute kits. Anyways, thanks for tuning in, guys. Hope you enjoyed it. We'll definitely do more. I'd like to hear your feedback. crest, the motor plates are actually in production, so we should have LS motor plates in production later this week, and also our billet fuel, mechanical fuel mounts. Those are all done in design. So our whole new mechanical fuel line will be coming out soon. We're hoping to switch that also over into Coyote stuff as well. So the LS mechanical setups will be readily available. We also have some alternator mounts that'll be available as well for your winter builds, as well as a whole other ton of stuff. But anyways, hope you guys have a great Saturday. I'm tuning out. We'll see you.